Thanks for introducing yourselves. So, you all know what the classes are. I put 277 here, so that's all. Office hours. So I'll be doing my office hours after this class on Thursdays, and Jeffrey is going to be meeting on Wednesdays. We can figure out if we want to do Zoom or in person, whatever you guys prefer. Is there a preference?
I can definitely do mine in person.
Yeah, I can also do mine in person, but I'll probably have a Zoom link mainly for Omar. So for class format, I am going to not focus too much on midterm and end term. As you can see, that's like basically 10%. We'll have a midterm quiz and an end term quiz. The main focus of this class is pay attention to what's happening in class. So we'll have reading assignments. Basically, I'll be assigning a news article, something cool happening in the field of AI, or a short paper, and then a few questions from that, which will be due before the beginning of the next class. So we'll talk about like next class's assignment today at the end of the class. We'll have 2 coding assignments, I think, so far planned. There might be one more, but so far 2 coding assignments, which are 15%. For coding assignments, we prefer Python. So I assume you're somewhat familiar. If not, we can discuss basics in office hours. We will have a basic intro to Python / intro to pandas and stuff coding soon. So yeah, if you have any issues with the code, let me know. The main focus of our class will be the final project / term paper. So the reason I asked what you want to solve is because my motto for this class is I want all of you to come up with a cool societal problem that you think is happening because of biased models or just unfair or irresponsible models. Collect data or grab data sources and then do a cool project showing the problems. And you don't have to do it right now. You don't even have to come up with an idea right now, but my hope is that you will walk away from this class with a really cool project that can go in your resume that can be published as a paper. Jeffrey and I have co-published a ton of papers and we get to go to conferences. That's a huge perk. But even without that, you don't have to necessarily publish a paper, but I want you guys to have a cool project, say stuff like, and we have done this, with our lab, we have found problems in Google search. We have found problems in Facebook ads, right? And these are all cool things you can say you have found. So the last time I TA'd, a few students found evidences of political polarization on TikTok. So somebody coded up a cool thing to measure what hashtags were being shown to somebody on TikTok when it was auto-scrolling. So they wrote a script on an Android phone. And if you set it to only pause and watch things tagged with, say, GOP hashtags and skip everything else, after maybe 24 hours or so, it will only show you that. So the recommendation algorithm is very, very biased in the sense it keeps feeding you more of what you watch, but never shows you anything else. So that was a cool project that those students did, and they have it under their belt forever. So that's the goal for this class. That's why it's heavily weighted. In terms of reading assignments, again, like I said, I will assign portions of research papers and or articles before the class. So you basically get half a week to do them. It's usually just one paper, read the paper and answer the following questions type of thing. We will discuss the answers in class, so you never have to worry about what the answers were before every class starts. I will upload these slides at the end of the class, so there's a cute link there talking about how to read a research paper. So yeah, that should be helpful. Coding assignments, few and far between. I don't want to just give a lot of coding homework. I want you guys to focus on the final project. And if you have problems with that, we will deal with that. The reason why there are a couple of coding assignments at all are because I want to make sure that if anybody has problems with doing machine learning on Python, through doing the assignment, you'll at least get to the stage where you can start doing a project. So that's the goal. But mainly I want to focus on teaching cool things. Quizzes, yeah. So these will be entirely from the material I teach in class, so no extra work. So if you have done the reading assignments and if you have followed the slides in class, you should be able to do it. So these will be very easy, just pay attention in class. But yeah, we'll have a midterm and a term quiz. And the most important thing is the term project. So I did write groups of 2, but I don't know, we are 8 people. Do you guys want to do it in groups of 2 and have 4 projects, or does each person want an individual project? What's the consensus? Let's do it individual projects. Let's just keep it that way. We'll have more cool things to discuss because it's a much smaller class than would have been. So Jeffrey has made a nice format of what the final product should look like. So basically, in the end of the class, I want all of you to have a term paper where you talk about the different sources you consulted, what's the background, which other researchers have discovered other things in the problem you're tackling. So for example, if somebody was writing the TikTok political polarization paper, they would introduce why they were motivated to do this. And one problem is political bias on online social networks. That was the motivation. In terms of background, what they consulted to come up with the plan for the project. Like, okay, other people have already looked at YouTube polarization, so I wanted to look at TikTok. That can be a possible background. Talk about methods, talk about results, and yeah, it should be a really fun experience. And you're expected to build this over the course of the class. So please don't rush and try and finish this in 1 week. Just slowly build towards it, and we will be helping at every stage. I think we are going to have at least 2 project discussion classes before we have the final presentation. So we will monitor how much you've done. Like you can do up to background and show us, and we can help you say, okay, you might have missed this research paper. Look at that, or look at that method, or look at that code on GitHub before you actually start doing the project. So we'll be happy. For this class, I prefer everybody uses Overleaf to submit, to create PDFs and submit them. All the templates will be linked in class. So you just literally click the template, make a copy, and create a free Overleaf account for yourself, paste that code, and then modify it to have the final PDF. Has anybody used LaTeX before? Oh, so some of us know. If you have any issues, please ask. Well, with that, let's start. Oh. So AI is powerful. We all know, like now in the news, how messy and powerful and just generally destructive or constructive AI can be, right? People have made robots. Most recently, I was reading something really cool, like somebody made nanobots to deliver drugs into specific cancer sites because chemo destroys good cells. So that is a really cool innovation of AI, which can save lives. But on the other hand, AI can do really bad things. If not trained properly, a drone can destroy an entire city if it was mal-targeted. All sorts of bad things and all sorts of good things. But for the most part, when you talk about, like, when you go to your residence hall and start talking about AI, people will be generally enthusiastic, right? ChatGPT is so cool, it can do this. And we are looking at AGI, we're looking at general intelligence, we are talking about things like Terminator. But there is a big dark side of AI which we don't think or talk about, and that is the motto of this class. So AI is very powerful, but we need to harness the power for good, and we need to do it responsibly. And I hope you appreciated the meme. So we will, at least in this introductory class, we will go through how or what bias even means and what irresponsible AI even means, right? I'm going to be asking a lot of provocative questions. So today's class is just introduction, and this is going to be discussion before we dive into actual course materials. So I want this to be super interactive. What does responsible AI mean? So there are many things that entail responsibility, right? It's not just fairness and bias. I mean, fairness and bias is important. You have racial bias, you have gender bias, you have age bias in algorithms, right? The same algorithm, let me see, Google's face detection algorithm mislabeled darker skinned people as animals, which became a massive incident a few years ago. But it did not do that for people with lighter skin. So that's an example of unfairness. And releasing such a product without testing, that was an example of irresponsibility. But beyond that, there's a massive scope of responsible AI that goes beyond bias. So we'll also talk about those things in class. So we will talk about explainability. So if a model has made a prediction, right? If a model has said, Ben, you did not get a new credit card. Why? What were the reasons? Like, what qualities did you have that the model think made you ineligible? Most models today just provide a final score, like this person gets this credit score, but it's not really explained. And these models are just trained once and deployed out into the universe and can destroy somebody's financial transition or financial, path, right? If you didn't get that loan, you can't buy a house. And these things keep building on. Systematic injustices which are not explained, without them, people can't really tackle. If you don't know why you didn't get the loan, you can't bring a case against anybody. So yeah, we will talk about explainability, we will talk about transparency, which are two sides of the same coin, but also transparency additionally includes transparent practices. Like even while designing a machine learning model, you want to upload your data. You want the entire data collection process to be transparent. You want the entire training process to be, as clear as possible. You want things to be open source. OpenAI, for example, OpenAI, none of their things are open. So if we wanted to know what was going on under the hood of these models, we couldn't. Then we will talk about in this class about privacy, which I think is another interesting thing that people don't think about. So these large language models, are people familiar with what large language models mean? So large language models, or just generative AI models, fully memorize information sometimes. And while we think that the things it is generating are new, more often than not, they're memorizing people's personal details. And with very little prompting, you can get it to spit out things like credit card information. If somebody had a medical diagnosis. So these massive models memorize information and cause privacy problems. A lot of large models are trained on things like medical reports or criminal records. And this information that these people probably don't want it to be out there, right? There's things like right to be forgotten. Models that have memorized this information can't really have this sort of forgetting policy, or at least that research doesn't exist yet. We are working on it. But until then, if you have ever had any public web page out there, ChatGPT has probably ingested it during its training. There was this really cool piece by the Washington Post. I will share it on Piazza at some point, maybe. Sounds really cool. They actually went into, basically they asked OpenAI and asked other people where you trained your model on, and they were able to publish a huge list of web pages which were crawled to train the model. And it included things like journalists' personal blogs where they were talking about their cat dying. And this is probably information they don't, for example, even if I have a public blog which I treat like a journal, I'll probably not share it around it. But now, because of that implicit association, when you search that journalist's name, extremely personal things are being spit out by ChatGPT about that person. So we will talk about differential privacy and what it means in machine learning. Safety. Safety is a new paradigm. We have been talking about fairness and bias for a while now, but safety is a newer thing. I'm not an expert on safety, but what it generally means is this existential crisis people. Basically, there's this group of people who think that if you train large AI models without stopping to align it, we will talk about what that means. they think that these robots or these models can destroy the world. And therefore, humans are at a critical junction where our existence can be threatened by models, by robot overlords. Again, it's a very philosophical thing that I personally don't subscribe to, but it's important to know because this is the class of thinking that exists. We will talk about existential slash safety people. And finally, I would say this is like probably my new favorite thing to do is talk about regulations and policy. So in this class, we will discover all of the problems like these that exist and all of the methods that people use, things like differential privacy or things like explainable models or things like fair classification systems. But nobody is obligated to do these unless there is regulation, right? If you are a company doing bad things, the government says that you cannot do these things, they will continue to do them. So I am really happy that in this class we will get a chance to talk about things like the AI Act in Europe, right? And talk about things like the White House Office of Science and Technology Policy's blueprint of AI rights. So efforts being made by lawmakers or by scientists talking to lawmakers through depositions and stuff like that to try and change the law so that companies are forced to do the right thing. Because otherwise they will just make a model that generates the most profit, but continue to say not give loans to one group of people, thereby continuing to destroy their lives while increasing their profit, increasing the company's profit margin. Also, the other fun thing is that we will sometimes have guest lecturers. So I've tried my best to have one guest lecturer for each of these topics. They're all experts in their area. So I will announce them as the days get closer because I'm still waiting on some confirmations, but we will have people from Spotify talking about how they do fair recommendations. We will have someone from the UK government talk about how they are designing UK policy on fair AI. We will have somebody from Google Brain talking about what they did to ensure privacy and security in their large language models. So I'm super excited for these people to come in. And I hope that you guys will ask them cool questions, give them a hard time, but then learn something cool in the process. So let's talk about fairness and bias for a second. And this is a cool video that I want to show in class. Let's just look at the video and then we will talk about what we learned.
Hi, I'm Joy, and I research how computers detect, recognize, and classify people's faces. In my TED featured talk, I spoke about my experience with the coded gaze, my term for algorithmic bias. The system I was using worked well on my lighter skinned friend's face, but when it came to detecting my face, it didn't do so well until I put on a white mask. After my talk was posted, I tested my speaker image profile across different facial analysis demos. 2 of the demos didn't detect my face. The other 2, well, they misgendered me. The demos didn't even distinguish between gender identity and biological sex. They just provided 2 labels, male and female. Now I wanted to see if these results were just because of my unique facial features or if this was something that was more of a pattern across other faces too. So I began a project that became my MIT thesis, Gender Shades, or the long title, Gender Shades, Intersectional Phenotypic and Demographic Evaluation of Face Data Sets and Gender Classifiers, or just Gender Shades. I wanted to see how well different gender classification systems worked across different people's faces and if the results changed based on somebody's gender or their skin type. I created a data set of over 1,000 images of parliament members ranked among the top 10 in the world based on their representation of women in power. To get at a range of skin types, I chose 3 African countries and 3 European countries, so I could see how the system performed on lighter skin and darker skin. Then I chose 3 companies to evaluate. IBM, Microsoft, and Face++, which has access to one of the largest data sets of Chinese faces. So now with the data set and the companies, I decided to run a test. The companies appear to have relatively high accuracy overall. Microsoft performed best, achieving 94% accuracy on the whole data set. All companies perform better on males than females, and all companies also perform better on lighter subjects than on darker subjects. When we analyzed the results by 4 subgroups, we saw that all companies performed worst on darker females. IBM and Microsoft performed best on lighter males, and Face++ performed best on darker males compared to the others. IBM had the largest gap in accuracy, with a difference of 34% in error rates between lighter males and darker females. I was surprised to see multiple commercial products failing on over 1 in 3 women of color. In fact, as we tested women with darker and darker skin, the chances of being correctly gendered came close to a coin toss. While more research is needed to explore the specific reasons for the accuracy differences, one general issue is the lack of diversity in training images and benchmark datasets. Failure to separate accuracy results across traits like gender and skin type also makes it harder to identify differences. Companies should do better with commercially sold products, especially since the machine learning techniques that have made gender classification possible are applied to other domains of computer vision, like facial recognition, and other areas of artificial intelligence, like predictive analytics. Predictive systems can help determine who is hired, granted a loan, or what information a particular individual sees. These data-centric technologies are vulnerable to bias and abuse. As a result, we must demand more transparency and more accountability. We have entered the age of automation overconfident yet underprepared. If we fail to make ethical and inclusive artificial intelligence, we risk losing gains made in civil rights and gender equity under the guise of machine neutrality. The coded gaze reflected in the Gender Shades project must be faced.
That is an actual website, and Joy has done phenomenal work. Both during her time at MIT Media Lab and after. So now she runs Algorithmic Justice League, which you guys should subscribe to because they have a really cool newsletter and they talk about cool things that they continue to find. And they're very involved in grassroots type campaigns. So working with students, working with volunteers, and working with the government. In fact, Joy was on the cover of Time magazine this morning. As I think they have a thing on what? The most 100 influential, the 100 most influential people in AI right now, and she's one of them. So, great stuff. So as we saw in the video, predictive systems are on the rise. They have generated enormous benefits for business because IBM, Microsoft, and Face++ did patent or at least sold those products as subscriptions to companies without testing them for race and gender biases, right? So it was continuing to harm people. And one reason why this can actually have real life consequences is because, let's see, say a police station has rented out or has subscribed to Face++ to track defendants' facial features or like maintaining the database. If this model has biases or particular skin tones over the others, it means that it is less accurate for some skin tones and gender combinations than others, meaning that innocent people will be incorrectly labeled as criminals and will end up in the jail for longer than required, right? Until their identity can be verified. So that has dire social consequences. There was another thing that she mentioned in the video, which I don't know if you guys picked up on, but a lot of these machine learning models are encoded with historical definitions of what groups are, which means they were probably designed at a time when non-binary identities weren't as common as they are now. which means if somebody identifies as non-binary now, this model will more likely than not misgender them or things like match them to an old database and dead name them. And so they don't have these social considerations into effect. And companies are not motivated to do any better because this is profitable, right? They will rather spend their time on signing massive defense contracts with the government. And I think Amazon had a product, facial recognition product, which some journalists tested on images of senators in the US Senate, and around 40% of them were incorrectly labeled as criminals. So this is a product that Amazon has been successfully selling to the US government to be used by people at border control. So imagine how many people are incorrectly not let into the country or jailed or something. I'm glad you guys are interested to do better as future computer scientists, improve the world, and I'm glad I get the opportunity to talk about this stuff. So let's maybe go through a few more examples before we ask sort of discussion questions. So yeah, I mean, this is from here. Yeah, I mentioned earlier in the class, there are AI technologies in every phase of the world. You have AI in sports. So in newer, I believe, baseball and football games, people use machine learning models to show different camera angles, but then also 3D projections. So AI has helped umpiring a lot. Medical diagnosis, I mentioned the nanobots, which are delivering cancer drugs. Workplace analytics, my company, Adaptity. So the work I do at my company is I help write machine learning models to match candidates to jobs, but instead of using their degrees, our company wants to look at their skills. So say you have been a bartender, for example, for 10 years, you probably have transferable skills, things like hospitality skills that you can probably use at a different job, like being a flight attendant, and thereby make more money. So, I mean, our company is based on a mission to help people find better jobs faster, and we target people who traditionally, for whatever reason, have not been able to go to college and therefore don't have degrees, but may have skills that they can use to get better jobs. So we work with affinity groups and African-American employers and companies to improve hiring diversity. But that is the second point, how AI can revolutionize today's workplace. Legal practice, similar things. There are generative AI use cases for law. There are dangers and pitfalls, yes, but it has reduced a lot of time for paralegals because models can generate summaries of massive documents very quickly. So you don't have to read full documents. That's a good use of AI. So given what you now know after seeing the video and everything, do you think we can trust a machine to make the right decisions about a person's future? Any volunteers?
In the examples, there's a lot of biases. You gotta work it out and see what you can do to improve these machines.
So I think what he's saying is we should use models carefully, but probably think twice before deploying it to something that is mission critical, something like health or criminal justice. That is correct, Adrian.
I think a lot of times, like the credit example you gave, it's almost like a black box. You don't understand this. If you add like a human or someone else's opinion in addition to the machine, then maybe I think that we just using the machine.
Good. That's a fantastic observation. There is an entire line of work which looks into human in the loop type of solutions. So have a final decision maker look at not just a number, but what that number means. So, right. So if I am a person sitting in a bank with an algorithm on the side, if you are the customer who has been rejected for a loan, I should be able to tell you why this happened and not because I felt like it or because the model told me so, but because of certain factors. So you touch on interpretability. Anybody else? And Omar, by the way, you are also open to share your thoughts.
Cool, thank you.
I think, what are you speaking?
No, I mean, I was just gonna echo what everyone said, or kind of what you summarize as, like, at least for now, AI should not be really used in really key or mission critical scenarios without any human intervention. But I think it's still such a bias, but for kind of low stakes case where we're just trying to increase productivity, I think it's definitely applicable.
I agree. I think going ahead, if you want to talk, just use the raise hand thing so I know to see you. Also, I don't know why the room cameras aren't working, but we will figure it out for the next class. Sorry about that. Yes, I think we generally agree that machine learning is useful and can help people, but we probably shouldn't let just a machine decide somebody's future, because a lot of historical biases and patterns are baked into these models. So until we know what's going on, we probably should be careful. So skepticism is healthy, and businesses have learned really painful lessons about the dangers of machines creating their own algorithms. So to give an example, so does anybody remember or know any of these examples? I think the first one was this bot called Tay, I believe, which Microsoft released on Twitter. And she was programmed to learn from talking to other people. People on Twitter just started like sharing horrible things with the robot. And eventually in the end, she started saying things like, I love Hitler, and just disgusting things. So that was a weird lack of foresight on their part, because they didn't think about what people would do outside of a controlled lab environment, right? Like somebody sitting at Microsoft Research probably gave very innocuous test examples, like, hi, my name is whatever, I live here. Do you remember, sorry, can you recommend some things near where I live, stuff like that. But it did not realize that in the open world system, people will do bad things. Second thing is an example that I gave earlier, and all of these are Googleable examples, by the way. So if you want to look up after the class, you can. Google Photos app, does anybody use it? I use it, cool. Google Photos app will sometimes auto tag and create albums, which uses machine learning, uses image recognition. A person who was Black, she and her brother had a selfie, and Google labeled it as gorilla. And they saw that and took a screenshot and uploaded it on Twitter, and it became a huge scandal. And Google's solution to this is actually really funny. Instead of fixing this bias problem, they just stopped labeling anything as gorillas. Even gorillas are not labeled as gorillas. So they didn't fix the problem. They didn't fix the algorithm. They just removed one label to just appease this PR disaster that happened. I don't remember what happened with Flickr, but something similar. Like they probably, yeah. I think I might be fully wrong. Just look this up, but I think Flickr was labeling only Western marriages in church, where people were wearing, women wearing gowns, men wearing tuxedos as weddings, but not say like Indian weddings. Even though they were a wedding, that auto tagging feature was not able to identify weddings from other cultures. So group bias problems. But how do these algorithms become biased? Like we have talked about the bias problems that people find and discover and create Twitter PR scandals, X PR scandals. But maybe we need to think about how they became biased in the first place. Like, was somebody at Google sitting and telling the algorithm to label somebody with darker skin as a gorilla? Probably not. Then how did the model learn to become biased? Maybe actually, yeah. Does anybody have guesses before we talk about this? Yes.
Bias,
Yes, that is one reason. A lot of criminal justice databases did not remove, okay. So how bail bond works in the US is you pay cash bail to get somebody out of jail, even though they are not convicted, they have just been held. So you have to pay cash bail to get them out. Sometimes people who are from poor neighborhoods don't have that sort of money. So they stay for the entire time required before they are either acquitted or convicted, because they don't have the money to get out of jail. So that information gets logged into criminal justice systems. So time for which a person was held in jail. So essentially, if you train a model that takes as one of the features time that person was held in pretrial jail, that just is by default longer for people who did not have money to bail themselves out, even though they were innocent. So the model just then unfortunately learns to predict poor people as criminals, even if they weren't. So yes, the world is biased, the data sets get biased, and nobody thinks about these small things that because of how the US bail system works, these people are probably as innocent as the group that is being labeled low risk. Any other guesses?
I guess I don't know exactly how they work, but like large language models, like same thing. Like they're not necessarily training the model on like peer reviewed like whatever like accurate data sources. So if there's like blogs or like personal opinion articles, whatever that exists on the internet, they're training based off of that. Like if you are trying to output information based on the topic you're interested in, it could be inaccurate or like biased in terms of how society views some topic.
That's a fun observation. So a lot of online LLM training data comes from massive dumps of Reddit. And Reddit is not really known for being socially or culturally sensitive. So a lot of these anonymous 4chan-esque or Reddit-esque data ends up into these systems. Thereby it learns these dangerous patterns of association. So yes, that is a very cunning observation.
Is it like for large language models, like would it be feasible to like do like a segmented approach, like, oh, these are peer reviewed, so like this is one tier, and then there's another tier that's like 4chan, and then there's another tier that's like Reddit, and you attribute like certain like levels of like accuracy to like the tiers.
So the way large language systems currently work, or sorry, the way people have adopted it is to train on everything ever written on the internet possible. Because what they are trying to find is whether this massive model with billions and hundreds of billions of parameters learn internal representations. We'll talk about what internal representations are in next class, but whether they can find patterns in every text ever uploaded on the internet that can describe humanity, and can it become intelligent as humans by just knowing everything. However, you are right, when you take that approach, individual sensitive things become less accurate. So a model that's been trained on credit data, but also medical data, but also everything on the internet will probably have lower accuracy on medical data than a separate language model that was only trained on NIH data or something. It will be better at medicine, but bad at other things. So in terms of, I wouldn't call it segmented approach, but I know what you're getting at. There are reports, we don't know because OpenAI did not talk about it, but GPT 3.5 or ChatGPT, the free one, was a massive model that was trained on everything and it tries to repeat everything. But there are reports that GPT-4 is actually a collection of submodels. So there is a top layer that decides what is the closest model for that topic, and then the response comes from one of the underlying ones. So they never published how many parameters are there in GPT-4. But there were internal reports and rumors that they have trained smaller models to be more accurate for that field. Google has their competitor to GPT. I believe their model is called PaLM, P-L-M, and they have made a medicine-specific one called MedPaLM. So MedPaLM is supposed to be more accurate for medical diagnosis. So yeah, to answer your question, I think that is a good intuition to have. Various companies are doing that. One thing that all of you alluded to but didn't actually talk about is another social source of bias, which is algorithm design. So the bias is not just because of the data, but also how you design an algorithm. For example, the criminal justice example that I gave you, if somebody was not feature engineering properly and not taking this feature, which is faulty to begin with, out of the training, that is a design problem. Or if you have trained a model to, I don't know, there is an example in the medical literature where I believe someday at Harvard wrote this paper, Dr. Obermeyer. He was a opening speaker, keynote speaker this year at FACT. So he trained a model to optimize the total medical cost of a patient. Or not he, but I think that model exists, he investigated. But there was a model that tried to reduce the total medical cost on a patient by cutting on different things like ambulance time spent on that patient or number of visits and this and that. And because of that, what ended up happening was that patients who were from low-income neighborhoods that did not have access to the T, right? Like somewhere in the middle of Somerville that did not at that point of time, now we have the Green Line, but did not have access to transportation. These patients were not able to show up to appointments quickly and often missed appointments. But then that showed up in the final optimization part as a lower cost patient. So they were assumed to be healthier because lower cost patients are healthier. And so when the model was being finally audited, the makers of the model said that, oh, we see that the cost incurred to the hospital for both white and black patients is the same, so our model is not biased. But then when the author went back into the entire system and checked for what the inconsistencies were, he concluded that optimizing the total medical cost was a faulty design to begin with, because that was causing people to just not come to the appointments. Appointments were being auto-canceled by the system because they lived in a poor neighborhood. In fact, they needed more help there. And if they were provided with assistance from the hospital to come for checkups more quickly, they wouldn't be as sick to begin with. So it would still reduce the total cost, but it was the wrong thing to look at to begin with. The outcomes for everybody would have been healthier. That was the conclusion. So yes, data sources are not the only reason for bias. How you design your model also becomes another source for bias. We'll talk about this more, but that's a huge misconception that everybody has. So in the future, if somebody tells you that, oh, if we fix the data and if we collect data more in a more biased way, our model will not be biased, that's not true. Things like blind optimization for accuracy or cost can completely ignore other societal factors and still drive a bias anyway, even though your beginning data set was balanced to begin with. Yeah, did anybody have any more inputs before me? So yeah, what's wrong with this code? It's literally looking at a person's ethnicity as a sensitive attribute. And this would like immediately land a person in jail because of a bunch of laws that are being violated, civil rights era laws. But models don't have intentional bias. Yes, a lot of AI bias problems that we have are unintentional. So, before machine learning algorithms were written by humans, literally people used to write if-else statements in things like COBOL and Fortran. There were handwritten rules. There were like to detect whether something was a face, there were pixel rules like take an image, crop it into a square, see locations in the top left half and top right half. If there are two dark whatever, then that is probably an eye. So this whole thing will be a face. This is before machine learning. But if somebody induced bias in a handwritten rule system, that would have been easy to fix. That's probably not what happens now anymore. So what's the problem with this code? Yes, but also if anybody wants to look up the zip code population for this specific area, it is a highly black area. It's an example of using a different feature, so somebody's address and not their ethnicity, to still do the same type of discrimination. At least in the US legal system, you are not allowed to use people's race, gender, and a bunch of other things to do predictions. In specific things like credit lending or housing models. So what a lot of people do instead are just take away these features. So take away somebody's ethnicity and gender information away, but then send everything else into the model. When you do that, because of historical biases in the data, the model will learn that that zip code people from that zip code have been denied a bunch of loans in the past, so I should continue to deny people from the zip code. So even though such a rule might not be handwritten, it becomes a source of indirect bias that causes the same problems over and over. So this is less obvious. Unless you knew to look for that zip code on some sort of census distribution, you would not know that this problem was happening. But this is again still easy to solve because it's a handwritten rule system. Nobody writes machine learning models like this. But this was an easy example to spot bias. What happens when we actually look at bigger things? So when you have a statistical model, and do people know what statistical models are? Are you guys familiar with things like regression? So in a regression model, these biases can still exist. They're not handwritten rules anymore, but you can look at the weights of individual features. And a skilled statistician, which I'm sure you guys are because you probably have taken some statistics courses, you will be able to see probably some example like, oh, it looks like the zip code weight for certain zip codes is more than the others. So something fishy is happening here. You can go in and fix that because those parameters are visible and therefore transparent. Like a regression model looks like, alpha x1 plus beta x2 plus gamma x3. So you have x1, x2, x3 information and you have alpha, beta, gamma. You can look at what the weights are. You know what features are going in and out. So it's still easier to fix. What about a decision tree? If there was a bias in there, would it be as easy to fix now? You could still trace the tree, perfect. So decision trees are an example of an explainable model. Literally, it's a bunch of if statements all the way down. So say you're trying to predict if somebody gets a loan. So something like, is this person's credit greater than 700 or less than 700? That could be the first step. Next step could be something else. Has this person ever been evicted? Yes, no, so on and so on. So if there was systematic bias, you could trace all the leaves and see at what point was there a faulty decision and switch that out and see if it becomes more fair. So it's a small section of a decision tree. Decision trees can be massive. In fact, there are theories showing that you could possibly convert any machine learning classifier into a decision tree if you had enough of these nodes. But yes, far less obvious than the first two examples we gave. So when sometimes one thing that is not easily noticeable is you might have individual examples of things that are not biased, but when you combine them, then a model becomes biased. And one cool example of this is something like when you measure things in terms of intersectional groups. So an example, we write it here. And we will talk about this more later in the lecture. But say you have a model where X's are people who were denied a loan. O's are people who received a loan. Say this is male, female. Say this is black and white. What happens when you only look at race? Does this algorithm seem fair to you? If you only look at race and not gender, see how many people have passed and how many have failed. It looks fair because 6 people have passed and 6 people have failed. When you only look at gender, so it's not 6, sorry, 3. When you look at gender, 6, yes. 3 out of, 3 men have passed and 3 women have passed and the others have failed. But when you look at combinations, you can see that there are certain groups like black females and white males who always fail. So it's not enough to make one model fair if you are in a company or an organization where you have like 100 models working together. You have to see what the final effect is on all sorts of intersectional groups. So this thing came out first in a paper at UPenn. Christian's colleague.
I think the professors are Michael Kearns or
Yes.
Aaron Knoll.
Michael Corner and Roth, they're really good statisticians and they have very mathy papers, which I find it difficult to understand. But Jeffrey, you're better at math than I am. But Michael Kearns came up with this really cool invention and he called it fairness gerrymandering because of how US political gerrymandering works. You can gerrymander certain groups to get unfair predictions over the others. So yeah, if you're in a company, say you are at Facebook, you are designing a social network feed. It has 1 million data points and has 1 million, maybe not 1 million, but has maybe 100 models working in tandem. Things like recommendation engines showing you topics that you probably like on Facebook. So that's one model. There might be a model to measure toxicity, whether something was really harmful, and so whether Facebook should suppress it or not. There might be, I don't know, any number of models. And individually, and what happens usually in big companies, I interned at Twitter twice. What happens in big companies is smaller teams are responsible for individual models. So there might be a team of 5 people working on the toxicity model. They are literally, their job was to design a project where a model says whether a tweet is toxic or not, like whether it is saying, go murder that some race or gender person. That is an example of toxic tweet. But they maybe have tested it to be fair for every group in their small world system. But when it goes out into the main timeline of Twitter, there might be another model that shows things that are relevant to you. So you might be a person from that ethnic group that might want to see more tweets that mention that word. So you might be invariably shown more toxic tweets than others. So what I'm trying to say is that when models work together, their individual considerations can become completely destroyed. So it is important for large organizations making millions of models together to do this type of post-hoc analysis and be careful about these. Here's the last one. So you think in a model like this, like a neural network model, would you be able to spot what features are causing bias easily? Network look like this. It's because these weights are a combination of the previous layer's weights and previous layer's, they're called biases, but that bias is different from model bias. Maybe we will not use that word, but say nodes and edges. So every node is a combination of weights of the edges and nodes of the previous layer. So basically none of them mean anything. Like these things inputs might mean things like zip code, race, gender, blah, blah. But when you go into these layers, these become higher level representations of things that are not easy to explain. And therefore bias becomes really, really hard to explain. That, my friends, is what we'll be doing for the rest of this class, but not this class, the rest of this course, is trying to explain the unexplainable. Look at really cool research techniques to see what happens when we peek under the hood. What type of analysis can we get by looking at the final data instead of looking inside the black box, as you said. And Jeffrey's an expert in auditing, so he'll be talking about post-hoc analyses some point in the class. We will be looking at methods that explain inside layers for transparency systems. So yeah, cool stuff. And so far with what we know as of this class, this is very obscured and black boxy, but don't worry, we'll look at cool techniques. So maybe that brings us to another question. Say you are OpenAI and you have built ChatGPT and people are discovering biases you yourself did not discover while you were doing that in the design stage. If OpenAI itself cannot fix a problem, do we have any hopes of correcting it? An example of this is, remember when ChatGPT first came out, professors were concerned that everybody would do their homework on ChatGPT. And so then OpenAI came up with the model to detect whether something was detected by ChatGPT. And then we found out that the model doesn't work well, so they retracted it. So even OpenAI can't say properly if their model works or not. So what do we think? Like, what can we do as people who are not even the designers of a model to fix this problem? I guess is the question. Thoughts?
The last part of the question.
So even the developers of these models are not able to fix these problems. So what do you think we as non-developers of these systems, but using them as users, what can we do? Like what hope do we have of fixing it?
I think as users, we just treat it as tools, not the solution. We just hope the machine learning, like ChatGPT, just give us more context, not the solution. Like, we as a user just think about the solution, like if it has a bias or not, something like that.
Like increasing education, like what you said essentially, but like teaching it in schools. And only like how to find bias like news articles. I feel like you need to have that kind of training for AI tools as well.
That's actually a very cool thing you mentioned. The Boston Public Library has an education, re-education and also education program, and they run camps on misinformation education. And people have talked about introducing misinformation education in high schools, but there has been political pushback because there are certain politicians who rely on misinformation to get votes. But yes, it's a very good suggestion of something we can do as a community is impart education and let people identify what is biased, what is clearly misinformation, and not fall prey to things like the Pope wearing a fancy jacket. Any other thoughts? And this is a very open-ended question. You can say things like, I want to become the next mayor so that I can ban AI. That is one solution. There is no right answer, but I'm wondering what you guys think that we can do as external agencies.
I feel like it's like policy because they're not like OpenAI isn't required to see how they're which parameters they're choosing and how the data is being trained. Then even like developers, like external developers, like aren't able to evaluate the model. So if there's like transparency requirements, which I feel like in America especially is like really difficult to have. Like Europe is like a bit better at it. I mean, I know so I think like and it does seem like that's something that like across the aisle in America, like something that like there's common around there. So I think like increased efforts for like, policy changes.
That is, yes, that is a very astute observation, and we will stress very heavily on this towards the end of the course when we start talking about policy and invite policy experts to talk to you guys. I think right now what we have in terms of policy is only the White House Office of Science and Technology Policies document, which is called the AI Bill of Rights. It's not law, it's just a thing published by the Office of the President. So it's meant as a guideline, but nobody is required to adopt it. So we do need policies with stronger teeth so that companies are forced to do things like, OpenAI should tell us what they did to train, to test. In fact, I would say argue for like even open sourcing the code. Because there has been an entire history of the field of deep learning where everybody used to publish papers and people used to discuss with each other and come up with cooler techniques. And then recently it has become a huge money-making game, right? Like everybody now sells models as subscription instead of uploading the model code on GitHub so you can download to your local machine and run it. And there are both cost barriers because newer models require fancy GPUs to run. But additionally, even if you had them, companies are fully not sharing the code. So it has also become a catalyst thing. So policy, yes, is a solution. Any other solution between, so there are two camps here. It looks like we are advocating for technical solutions to build correctly from the ground up. And we are talking about policy solutions. Has anyone thought of any in-between solutions? Maybe something with more participatory approach. So one thing that is very popular in the security community is hackathons. And there will often be companies that put out bug bounties, saying we have built this new system, now hackers go crazy on it, and I will give you $10,000 if you find a bug in the black box, like just see if you can steal people's information or whatever, some sort of stress test. Recently, in the field of machine learning bias, there's starting to be something called bug bias bounties, bias bounties. So an example of that was, we will actually talk about this like very soon, because I was at Twitter when this happened, but I don't know if you guys remember, somebody discovered that when you post a very long image on Twitter with say 2 different faces, it seemed to crop, like because the long image is not shown on Twitter, it shows a cropped version. The crop used to be focusing on people with lighter skin. So somebody posted 2 long images, one where Obama was on top and Mitch McConnell was in the bottom, and then swapped, and both images were cropped to McConnell's face. So that then started like this entire online frenzy. And so I worked with the machine learning ethics team at Twitter, and that was a new team when this happened, this scandal happened. So they took it as their first big project. And the way they did that is they just took out the source code for that cropping algorithm and uploaded it on GitHub and conducted a bias bounty. So invited developers to take the code, take example data, and see what happened. And people came up with 5 different solutions. And the team also did their own analysis and fixed it and then uploaded it. And we will talk about this in detail when we come to debiasing lectures. But that is another example. Like you can, if you are really interested to get community feedback, and often developers will be sitting in places like San Francisco in a very insular environment with like only white men in the room, not even know to test for biases. So opening up your machine learning system to feedback from the community is another valuable cooperative way. So developers can work in theory in tandem with people from different communities. Now, one problem of participatory approaches is that it leads people to have unrealistic expectations. One, somebody from our GIS community might not even be that tech savvy to begin with, that they can understand what's happening in ML. 2, it is unfair to ask for free labor from anybody. So when Twitter did that, that was like just for hackers or whatever, and then people said it's not participatory enough. You do not involve people from communities who are impacted by this. Then we did this last year. So I am part of this organization called Queer in AI. And last year at ACM, so the conference that I publish at the most is called ACM Fairness, Accountability, and Transparency. It's the top most premier conference for AI ethics related papers. Jeffrey and I have gone there. Like we went this year together. Last year only I went because I had 2 papers. That was in Korea. So with Queer in AI, we organized a Queer Bias Hackathon, which I'm happy to talk about more maybe in a later lecture. But in short, what happened was we asked people to take frameworks that already exist, frameworks of debiasing, frameworks of measuring bias, and say, okay, queer harms on the internet are difficult because they're invisible harms. I can see somebody and make somewhat of a guess of their gender or ethnicity. It's really not possible to look at somebody's face and say if they're queer. And if somebody's saying that, that's just wrong. That's just digital physiognomy, which is just illegal. Eugenics, basically. So don't trust anybody who says that you can write an AI gaydar. It's not possible. But because these are invisible harms, on the internet, you can face, as a queer person, somebody can face harms like a tweet saying, Happy Pride Month, I'm gay, can be flagged as toxic. And it has been discovered because in the past historical data, gay, lesbian, words like these were often co-occurrent with a very bad toxic sentence like a slur. So these toxicity models learn to just downgrade these tweets or whatever have you, social media posts as more toxic. And that was an example of invisible queer harm. Like your good posts are getting buried on the social media. Another example of queer harm is, again, similar, but like maybe on, I don't know, Snapchat, say that has a recommendation algorithm of locations, and you maybe went to a queer event and you shared about that on your Snapchat. You may stop being recommended to other people because of how models are designed if they're not designed carefully. So we had really a lot of fun. Like a lot of people came and attended, and people came up with a bunch of cool different frameworks. And that was better than the Twitter approach because it invited a particular community whose harms were not considered in the general population to give them a special platform, and we took away lessons. But then the problem with that was that it was held at a specific academic conference. So to go to that conference, you probably require to have a passport, to get a visa, to go to this country, to pay registration fees to attend the conference. And those things are not accessible to, say, I don't know, some queer person from the Middle East. They probably won't even come to this event because they are afraid of being identified for whatever sociocultural reasons, or I don't know, from some village in India. There might be queer people there who don't have the resources to travel to this conference. How do we include them? So the most recent thing that I was involved with was at DEF CON this year, which was a hacker conference. We did an LLM hacking thing. Everybody was given 50 minutes, 50 per session to just attack these models and do things like make the model generate something really bad about one particular social group, or get it to spit out somebody's credit card information, or get it to generate political information about a politician. So cool stuff like that. Because we learned lessons from the previous two hackathons, the organizers gathered funds from local governments and companies, used those funds to pay for community college students from across the US to come and participate, and their food and lodging was paid for. And then they were part of the bigger picture and were actively participating, and all of this data was collected and will be used to improve these LLMs. Some of them even ended up on the leaderboard. So if this funding was not available, people from community colleges who are not as fortunate as you guys, because you are at a very good school, but schools with lack of resources don't have the money to send their students to cool places like this. So we, as responsible ethicists or responsible tech people, should strive to hear more diverse voices and include them in participatory approaches by compensating them, like pay for their fare or pay for their hotels, so that they then feel inclined to discover problems in models which you can then fix. So that's the third way. So build models carefully, correctly from the ground up, from what you know from literature, then get feedback from participatory approaches, and also involve the policy buffer so that other companies don't do bad things. This is, I think, the last point of discussion. But yes, right now as it stands, what do you think companies are doing? Do you think they're overselling what their models can do, or do you think they're hiding things? Do you think they're doing something bad? What's the general consensus here? An example of this is like, I don't know, OpenAI uses terms like super intelligence. Do you think that's an accurate phrase for what they have built?
One of these vendors are over-reporting their systems capabilities. Like for the gender classification, we saw they were saying accurately for genders when they were still had the racial biases. And then for ChatGPT, if they're saying like it's super intelligence, it fails out like a riddle if you give it. Older versions used to fail at stuff like that. So like I think because of also how competitive the field has gotten so quickly, vendors seem to over-report, and like you said, they don't put out the code anymore, and you have to buy it and stuff like that. Like in the biotech and stuff, the software you have to buy to get AI for like protein prediction is like insane subscriptions, and they only give you like small data sets depending on like which system you're getting. I think they're over-reporting their capabilities, but they're not really providing.
That is largely correct. There is this entire discussion about AI hype. Hype sells. So if I have a company that has a lot of money to make, I will obviously say that my model is super intelligent and can write new plays in the style of Shakespeare and so on, without talking about the obvious problems that my model will have, because that sells. right? Because that's how you end up on places like CNN, which then you can use your political cunningness to basically sell an ad. We have come up with this. This is the most powerful thing that has ever been made. And if you don't use ChatGPT's capabilities, you'll fall far behind your peers because everybody else will use it. And therefore, basically peer pressure everybody into opting into your system. So I believe that, but also it's a large philosophical space of thinking. Some people believe in AI safety, AI doom, so on and so forth. We'll talk about that in class later. But at the heart of everything, at least something like ChatGPT's LLM is a text completion system. So instead of asking it a question, if you paste literally a paragraph of data in ChatGPT today, it won't say that I don't understand what is happening. It will try to complete that paragraph. So even the answer that you get from a question is a completion of a conversation that it thinks is happening. It's very interesting how these things are oversold. Another example is the Amazon facial recognition example I gave you. The company obviously managed to sell to the US military or CBP that our systems are 90 whatever % accurate without actually testing it on real people. They got that accuracy in their test data set, so they sold it without testing it on real people. There is a massive lack of post-hoc auditing or reporting because that policy doesn't exist. So because policy doesn't exist, companies put out a product and don't test it, and they only fix things when it becomes a PR disaster. We have this like very flawed system which is geared towards making big tech companies money, not responsibility. So I think we're close to the end of the class. So I'm sorry I didn't give a break. Next time I'll plan better to give a break in between, but we'll end soon. So in terms of principles worth defending, we want models to be fair, transparent, and provide recourse. So just a model being fair is not enough. Like, what does it mean? How can a computer judge a person based on something they haven't even done yet? Can you really be fair? Can you really fairly predict if a person will commit a crime again? Like, even if you have 99% accuracy, there is a 1% chance that that person will not commit the crime, but because of the model's prediction, you jailed that person. So criminal justice models are very fraught. Transparency is, I think, self-explanatory. There is no explanation. But the third important thing that I think we should be careful about talking when it comes to transparency is remediation or recourse. So, for example, say there is an employment model that takes people's information and says whether they should be hired as a fireman in the local fire station. And somebody got rejected. And so the model spit out a bunch of things saying, oh, you were rejected because your height is less than 6 feet, and a bunch of other things. That's not really an actionable explanation because you cannot increase your height and go back to the company to get hired. So I think when people design responsible models, this is very important. You have to give people a chance to change what was learned about them and not over rely on immutable characteristics like height, like race, like gender, like skin tone. These are not things you can change about yourself, but what you can change about yourself are things like a higher SAT score. So you can take the SAT again and come back with a better score. So that is probably a fair thing to provide as an explanation when something goes wrong. Something like length of time you have stayed at a particular address. That is something you have control over because you can stay at that address for longer before becoming eligible for some sort of program, which was maybe done through AI, but that's the thing you can change. What you cannot change are things, immutable characteristics about yourself. So we will talk about recourse later. This is a relatively newer subfield than the other things because it's just a hard problem. Like if an Uber driver doesn't match with you, but matches with somebody else, what recourse is there? Like you cannot force the driver to do something. Like they should also have agency. So agency is a fraught topic, but we will touch on it. And that brings us to the end of the class. Now, before we go, I want to talk about how reading assignments will work. So let me pull up. So basically, what you're supposed to do is read this paper. This is the first assignment, and this is a research paper from Nature. We'll not always have research papers. We'll also sometimes have news articles and so on. So I'll try to keep this interesting, but pretty short paper that talks about the history of ML and the future of ML. And then answer the following questions based on the text you've read. And this will be due before the start of next class. To help you actually write in that PDF, we have provided the overleaf template. So basically, just make a copy of this text file and create your own overleaf and fill this and then upload the PDF on Canvas. I will create the Canvas assignment, but yeah, it's due before the beginning of next class, so you have lots of time. And see you next class. I hope this was fun. Please give feedback. This is the first time I'm ever teaching a course, so I am probably as nervous as you are in the first class, but I hope we'll have lots of fun because I am really passionate about this topic and I want you guys to learn something cool and build a cool project at the end. See you next time. Oh.